The brain is the most complex part of the human body. This 3-pound organ is the seat of intelligence, interpreter of senses, initiator of body movement, and the controller of behavior. Lying in its bony shell and washed by protective fluid, the brain is the source of all the qualities that define our humanity. The brain is the crown jewel of the human body. There are around 1,000 billion neurons in the human brain. Each neuron has an association point somewhere in the range of 1,000 to 100,000. In the human brain, data is stored in such a manner as to be distributed, and we can extract more than one piece of this data when necessary from our memory parallelly. We can say that human brain is made up of incredibly amazing parallel processors. Have you ever thought how a human or an intelligent animal, recognizes and distinguishes things? When the eyes are open, visual information flows from the retina through the optic nerve and into the brain, which assembles this raw information into objects and scenes. Most of us will clearly identify that she is Angelina Jolie and he is Brad Pitt. Even if they have changed their appearance for, let's say, a new movie, we'll still be able to identify Angelina Jolie and Brad Pitt. Scientists and researchers wanted this to be done by machine. The idea of neural networks began as a model of how neurons in the brain function. In 1943, neurophysiologist Warren McGraw and mathematician Walter Pitts wrote a seminal paper on how neurons might work. So in order to describe how neurons in the brain might work, they modeled a simple neural network using electrical circuits. Inspired by the structure of human brain, ANN, that is artificial neural network, provide a viable solution to making computers more human-like and help machines come up with their own reasoning to problems. That is how an artificial neural network was born. Neural networks are a set of algorithms whose model is inspired by our human brain. Neural networks are designed to recognize and distinguish between patterns. They interpret sensory data through a kind of machine perception, labeling, or clustering raw inputs. The patterns they recognize are numerical, contained in vectors, into which data such as images, sounds, and text must be translated.